Hey and welcome back. So last time we made our memory map. Now our memory map doesn't really do anything. This is just a list. This is just something for us to make it easier for ourselves to plan where we want to put the different things. So we did a lot of math last time. We did a lot of planning, and we know where we want our character set and our sprites and so on. So this is just a list. Doesn't put anything into memory, because all of these are just labels or constants. So today we need to actually put the different things into our memory. So if we look at our main.asm file, it's almost completely blank. Only thing in here is our basic upstart code. Now I also made a file called game code, and that's almost empty as well. We only have this little loop here. So nothing's going on in our code right now. Now, in order for our code to know about this memory map, we need to include it. And right now, this file, this is our main file. This is where everything starts, right? Basic upstart 2. So in this file, we need to connect our memory map into that file. Now, the memory map itself is not going to take up any memory. These are all just variables. They don't take up any space. I'm sorry, these are all constants. So these don't take up any space in memory. But still, we need to tell our code about this file. We need to make this a part of our code. So memorymap.asm, that's here, together with the main.asm file and the game code file. So the way I connect this into my code here is simply by writing a hashtag and import. Then in quotation marks, I write the name of the file, memorymap.asm. So basically what this does, it just takes this file. So imagine we did this, just copied everything here, and we put it in here. That's actually what we're doing. But instead of doing that, I like to have separate files because it makes things super tidy, and we're going to do that a lot. We're going to separate things into different files. So it's going to become really tidy for us. And the bigger your project gets, the more handy this will be. Because we can have everything into one gigantic file, but that's going to be a nightmare once your project starts getting big. So by separating the different things, it's going to make things much easier for us. So now by writing hashtag import memorymap.asm here, I have basically said this thing, whatever I wrote in here, is going to be placed here. Still, we're not taking up any space in the Commodore 64 memory right now. Alright, so the next thing is a little interesting, because that's our gamecode.asm file, the one with our main and our game loop. So this file is going to take up a little space, and already we have a mnemonic down here which already takes up a few bytes, two or three bytes, I can't remember, but anyway, this is going to take up space. So now we need to tell our code that this has to be placed at a specific place in memory. Now, where in memory should we place our this game code file? Remember, we have our main label here. So let's go to our memory map. So what I said last time, game code address, I want that to start at 0810. So what I'm going to do right now, I'm just going to copy this label, game code address. So I'm going to copy that. And remember, this label means this number, so this memory address. So I could have written this memory address, but in order to make it easy for myself, I'm just going to write game code address. I'm just going to use that label instead. So I'm going to copy my game code address constant. And I'm going to go back to my main file here. So now I need to do the following. Now we've seen this before, but let's take a look at what this actually means. So I write an asterisk and an equal sign. In Kick Assembler, that's a way to specify a memory address. We talked about this a little bit before, but by doing this and, for example, a memory address like that, that means whatever comes after this, we're specifying a memory address, and whatever comes after this, that's where we're going to start filling in whatever we want to fill in. So code, sprites, whatever. But I'm not going to write a memory address now. I'm going to use my label instead, which is going to mean this. So now when I paste game code address here, that means 0810, right? But this is going to make it easier to read. Now, in addition to doing this, we can also write a little sort of a comment here. So in quotation marks right after this, I'm going to write game code. So why I do this is something I'm gonna come back to in a little while, because this is also very handy for us. Just writing a little code what this actually is. But now I've specified with this asterisk, I've specified, okay, now I'm going to start filling something in here. What am I going to fill in here? Well, I want to fill this file in there. So my game code file. It's called gamecode.asm, and it's in the same folder as my main file. So I simply write hashtag import, and in quotation marks I write gamecode.asm. So now I've just put this file here, and by doing this I know that my game code file starts at this address 0810. So it's not it's pretty much what we've done before, but this time we're doing it in a more tidy way. So because we're separating things like this, it looks a little more complicated, but it's the same thing as we've done before, except this memory map, of course. So alright, so now I can save this file. Now in my game code I have this game loop, so just to test to see if everything's working, I'm going to say inc and d020. So you remember this, right? Increase the border color. inc, that increases something in memory. What memory address? D020. So the memory address for the screen border color. So like before, it's going to make this color pattern in our border. So I'm doing that in my gamecode.asm file now. So back here in my main.asm file, let me run this to see if everything is working. So yeah, so there we go. So now I've run my main.asm file, and as you can see, the thing I just did here in my game code file, increase the border color, that's working. So I could do everything, like I said, I could do everything in my main.asm file. I could make a huge main.asm file, have everything in there. But I don't want to do that because it's going to be really messy once our code starts getting big. So this is an example of how our code is going to be structured. So let me just close this one. Now we know that this system is working. Here at address 0810, I have my game code file. That's a starting address of my game code file. In other words, this file starts at 0810, right? It's nothing new really. It's basically what we've done before. But we've done it in a little more tidy way. So now we have control of what's going on here in terms of memory addresses. So now I've placed my gamecode.asm file. Okay, great. Let's look at our memory map again. So the next one here is variables address. That's at address 0C100. So let me copy this variables address now. And let me go back to my main.asm file. And once again, I'm going to write an asterisk, equal sign, and then I'm going to paste in this label. And just as a comment behind it, I'm going to say variables. Now, what file should we put in here? Well, right now, we don't have a variables file. So we need to make a variables file. So I'm just gonna copy this heading. I'm gonna make a new file. In my heading, I'm just gonna say variables like that, and I'm gonna save it. So let me just save it here at the same place. Variables like that. So now I have an empty variables file, but that's fine. Variables.asm. So I want my variables to be at address 0C100. So copy this label in my main.asm file. Oh, I just pasted it in here. Okay, fine. So at 0C100 now, I want my variables. So once again, I write hashtag import and then variables.asm like that. So now I've put another file at a specific memory address. So now first I have my game code here at 0810, then my variables are going to come next at 0C100. So that's how I'm going to set up my file. So my main.asm file here, there's not really going to be any code in this file like that. This main.asm file is only going to connect all my other files and place them at the specified memory addresses once we run this code. So my game code is going to be at 0810, my variables is going to be at 0C100, and so on. So basically what I'm going to do is I'm just going to take every one of these and put them in here with this asterisk and an equal sign to tell my code here that I want to place these files at the specified memory addresses. So let's look at this next one, because that's a little special case now. So up until now we have written hashtag import and a file name like this, an ASM file. So that's what we're going to do when we're cramming code files in there. We write hashtag import and in quotation marks the name of our ASM file. But when we are going to include something like our tile set here, it's going to be a little bit different. So let's go look at our tile set file. Tile set now. My tile set file here, that's a bin file, a binary file. So I need to use a little bit different syntax. So first let me copy my tile set address, and that's going to be at address 0D100. So it's also a good idea to write these addresses in the correct order, starting at the lowest address and going up like that. So it's not going to be any sort of chaos for us. But my tile set address. So I'm going to go back to my main.asm file, and I'm going to write an asterisk, equal sign, and then I paste in my tile set address. So I'm just going to write here in quotation marks tile set like that. Now here comes the different part. I'm not going to write hashtag import now, because this is a binary file. Tileset.bin. It's a binary file. It's not an ASM file. There's not any code in here. So now I need to write, instead of hashtag import, I need to write dot import. So we use a dot instead of a hashtag now. Dot import and then binary. And then I can write the name of my file in quotation marks. Tileset.bin, like that. So importing binary files, as you can see, is a little bit different than importing ASM files. So we just need to remember that this import needs a dot in front of it when we're importing binary files, and a hashtag when we're importing ASM files. And in addition to that, we need to specify binary here after import. So it's a little bit different, but not a huge issue really. So we just need to remember those two different things. But as you can see, now I've included 3 files here in my main.asm file. Now the question is, can I run my file now? Let's try that. So I can run my file now. Now let's take a look at something where we can see visually our memory usage. And now this is going to come in handy. The comments or labels or whatever you want to call it after the memory address here. I wrote game code, variables, and tile set here. Now in just a second you're gonna see why that's handy. So now let me go here to my folder. So I think we briefly looked at this before, but here in my folder, once we run our code, this folder is created, the bin folder, and inside my bin folder I have my main.prg file. This is the actual file that we're going to use when we're done with a project and are going to play this game on the Commodore 64. This is the file we need to use for that. So this is our main binary file. And as you remember, we can just double click it and we can start it like that. But we also have this main build log file here. And this main build log file, that's very interesting for us. So let's take a look here. So if we take a closer look, if you can see, maybe I can zoom in a little bit here. Okay, let's see. Maybe a little bit more. like that perhaps. Alright, so there we go. So here's my main build log file. This is created when we run our code. So Kick Assembler is making this file for us. Now the important part in this file is this segment area. It says memory map here. So this shows us where the different things are. So for example, now we can see, all right, let me just do it that way. So I wrote game code here as a sort of a comment or whatever behind this memory address. That's going to show up here. So here I wrote variables, that's going to show up here. Here tile set, that's this one. So once we start to include a lot of stuff in our file like that, it's going to come really handy with these comments behind, because then they show up here. So by looking at this main build log file, we can see what the different things are. Like for example, what's taking up so much space in address 0C100? Oh, 0C100, oh, that's variables, right? So we can keep track of things like that. But here comes an even more important thing with our main build log file. Let's take a look at that. So there's a great web page here called Noice Kick Assembler Memory Viewer. Now we looked at this briefly before, but let's look at it again now. So if you remember, this is where we can take whatever's in our main build log txt file. So for example, if I now select everything in here, copy that. So copy everything from main build log and just paste it in here. So just by doing that, now we can see visually how much space we're taking up, or where we're starting to fill up in our Commodore 64 memory. So remember, this is the Commodore 64 memory starting from address 0 going all the way up to FFFF. So the entire memory of the Commodore 64. Now we just have these tiny little blue lines here. It's because we don't really have a lot of data right now, but this is going to show us where those different things are. So this bottom blue line, that's our game code file. This one above it right here, that's the variables file, and the one above that is the tileset file. So these are the areas where we're starting to fill up memory. Now the bigger your code gets, or the more complicated your code gets, the more handy this will be. Now if you did a proper job when you made your memory map, you did all the math correct and you did a lot of great planning, then you probably won't get any surprises in here. So for example, you planned that your sprites would go from 2000 to 3000, for example, then you should see that this area would be blue. So this is of course completely in line with our memory map. So it's just all of this how to be tidy when making your code, when programming. In the entire development process, the more tidy you can be, the easier of a time you're going to have. So we are not going to have any chaos here. We're going to know exactly what we're doing all the time. And filling in things at the right position in the memory is going to be super important for us. So now we've connected 3 of our files in here. Our game code, variables, and tileset. And we know exactly where they go in the memory. So let's do 2 more here. So let's take a look at our memory map what's next? Well, last time we did the tile set. So now this is the char set attrib, character set attributes. That's the one next. So I'm gonna copy that one. And just like before, I'm gonna start with an asterisk, an equal sign, and then I paste my label in there. And as a comment, I just say char, let's see here, char set attrib, like that. And the question now is, do I use hashtag import or dot import? Well, I need to check my file. This is the character set attributes, so the char set attrib. That's this file, char set attrib, and that's a .bin file, so a binary file. Which means I need to use this one. So dot import binary and the file name char set attrib dot bin. So now I put my character set attributes file at this address. Now the next one says HUD address. That's at address 0f100. So I'm gonna copy my HUD address, go back to my main file and say asterisk equal HUD address, and I'm just gonna write the comment HUD there. And my HUD file is also a binary file, so I need to write dot import binary, and I think the file was just called HUD, right? Yeah. HUD.bin. So now we haven't talked, we have mentioned HUD a few times, but we haven't really seen what that is. So how did I make this HUD file? Well, let me show you. So here I am back in Charpad. So we made a few rooms here, just some examples, and we started to make some graphics at the character set. Now I've made a few more down here because, as if you remember, I said in this cyan area I wanted that to be dedicated to HUD graphics. So I'm gonna have text and just normal text and letters up here. This purple area is going to be background graphics, and I want to dedicate this lower area to HUD graphics. Now the reason I did it that way, because now when I'm in this tile mode, I'm drawing with tiles here, right? So we made these tiles and we can draw with tiles here. Now tiles, they are 2x2 characters, right? So the thing is, we only have 64 tiles. That's a limited number. I don't want to, let's say I want to make a lot of fancy graphics, a lot of fancy backgrounds here. I don't want to spend tiles to make some simple HUD graphics. So now, since this is really a simple system, a tile is nothing magical. It's just 4 characters put together like this. So it's no problem to mix and match tiles and characters. And that's what I'm going to do. But in order to do this, to make it easier for myself, I'm gonna make another, or I have already made another Charpad file just for the HUD. So here is my HUD. So I made a new Charpad file, and I did not enable tileset for this one. So I said width 8, height 24. Now since I did not enable tileset here, these are in characters, not in tiles. So this is 8 characters wide and 24 characters tall. And I also, from my file here, I exported and I exported the character set and the character set attributes. So this character set here, I exported it from there, And in my new charpad file here, I imported it here. Import character set and character set attributes. So these are the same now for both my files here. Now, of course, they are not updated. So if I make some changes here, it's not going to reflect my other file here and vice versa. So this might be a little confusing. Maybe you want to do it another way, whatever. This is just one way that I'm doing it right now. But the point is that by doing it this way, without using tiles, I can just make, I can just make a HUD like this with single characters. So that means that I don't have to use any of my precious 64 tiles here to make some graphics. So I don't need to use a tile for making the corner like this or whatever it should be. I just construct a HUD here, make a fine little border and the right score and whatever. So I just do that here in a separate file. And when I'm done with that, I just say import export binary. And last time when we did this, we did this flexigrid thing. Now this is not a room, it's not a level or anything like that. I just want to export the characters here. So what I did was import export binary export map, a simple export map. That's just going to export whatever I have here. So it's going to export these characters, these characters sequentially like that. So I can read them back in my file, and then I need to make a routine. So we need to have two routines here. One routine that's going to draw tiles like this. One routine that can draw characters like this. So we're going to come back to that. But the point here is that this is the HUD. And since it's 8 by 24, we've done the math before, we end up with a number that's not 256, which means it fits perfectly here just before the address 1000. So that's the HUD. So now I've crammed in quite a lot of things here. We also have this one, our memory map crammed in here. But remember, that's just for convenience. This is not going to be crammed into memory because these are just labels. They are not part of our code. They're not going to take up any space. So, but of course it needs to be here to be a part of the code. So that when you run this through the assembler and later in the code, where there's a place called like this HUD address, the assembler knows what that is because we have our memory map up here. So, all right, now let's look at the finished product so you can get a little feel of what this is going to be. So here, this is the finished game. So here I have my main file. And of course it has a lot more code and stuff in it since this is the finished thing. But the important part I want you to see here is that I've separated things a lot. So here is the folder structure. So I made a separate folder for charpad files. I have a separate folder for spritepad files. Those are the project files. So I've just used this, I don't remember what the name of this sign is, but the upside down I. So if you do that in front of the folder name, and those are going to come at the top of the list of the folders. So just to get them out of the way, because these two are not going to be part of the code. These are just the project files, right? But anyway, then we have the bin folder, we know about that. But then I've created separate folders for the character set. So here I have character set and character set attributes. I have a separate folder just for constants. So here I have a lot of constant files. So for example, screen constants, I've separated into categories. So if I open this screen constants now, you can see that, for example, here we have screen border color D020. So basically a lot of these constants are just labels for memory addresses. So I don't have to remember D020. I don't have to remember D021. I just remember screen border color, screen background color. So this is the screen constants, just as an example. Then we have all kinds of constants, sprite constants. So these are the sprite constants. So again, you can see there are memory addresses. Sprite X position, sprite Y position, and so on. But the point is that I've separated them into, like I said, different categories and put all of those constants into a folder called constants. Then I have, for example, here I have a folder called variables. Now here are my different variables. So for example, I have tile variables down here. So these are the variables that has to do with tiles. Now let me just briefly mention while we're at this right now. So there are so many words, terms. You can basically make up your own terms if you want. But tile, that's the thing where you combine characters. A character that's just a simple character. Now, they are so closely related that I said with this code that I'm going to put them together. So, might be confusing, might not be confusing, I don't know. But in this case, you can see I put them together. So I have tile number, tile row, tile stuff up here. Then I have char. So also have some char stuff in here. So basically the reason I did that because I don't want to make as many files as possible. It's not a competition to make a million files. So at some point I just say that these things are so closely related that I'm just going to put them together. So I just wanted to mention that so it doesn't get confusing. But anyway, this is the file for tile variables, which in this case also contains a few character variables. But the point of the whole thing is that I've separated things into folders, and within the folders themselves I've separated files that has to do with a certain thing. System variables. I have a thing for system variables, for example. And we haven't looked at this before, but I've briefly mentioned it. Code libraries. That's this libraries folder. So in here, this is the logic itself. So here we have all the code that makes stuff happen. So in my room library, for example, this is where I load a new room. Or, load a level, if you want to call it that. So this is the code for that. And we also have code for handling sprites, stuff like that. So that's the libraries folder where all those things are. So I tried to make it as tidy as possible so that I know where my different things are. But when we're talking about what we've been talking about since the beginning here, adding things into memory at certain addresses, I've come up with a new term, a new name for something. I just called it includes. So I have a separate folder here called includes. So what's in that folder? In my includes folder, I tried to sort of bind things together. So for example, I have a file here called variables. Now in my variables file here, there are all my files that are in the variables folder. So my variables folder, that's this one. And let's see if I can, there we go. So here in my file variables, that's where I say import and those files that are in there. So in my main.asm file, I can just say import the one file called variables at that specified memory address, just like we did before. But I say import, and when you need to use a folder, when you're doing this, you just write import and slash folder name slash and then the file name. So as you can see here, variables, I used the folder includes and the file variables asm. So this file. So there are sort of two layers. First, I connect this file, but this file contains the actual variable files. So it might seem like some sort of unnecessary complexity. This might seem like, well, this is too much work or whatever. This is not necessary. So again, this is just how I do it. But for me, this has been super useful because, as I said, now I know where everything is, both in where things are placed in memory, but also where things are placed in my folder structure. So if I need to, for example, I need to add a new variable for sprites, I go into my variables folder here, and there's a file called sprite variables. So I just open up that, and then I just add another variable that has to do with sprites. So for me at least, working with my code this way has been super useful. And by doing this, using this includes system, it also makes it easy to, so I could have, instead of using this extra file called variables here, I could have written several files under here. So let's see, I could have written, there we go. So I couldn't have written all these files here if I wanted to. So that's really up to you what you want to do. But I just felt that doing it this way, by having separate files where I include the different variables, that just made sense to me. Again, there are no perfect way of making codes, but this is how I did it. So hopefully you can see what I did here. Just by so for example, there's in my includes folder, there's a file called tables, and you can see that it's from the tables folder, and these are all the table files. So it made sense to me, and it works out great in terms of planning where I want to have things in my memory. So yeah, we also and by the way, I also made a folder here called system, and that's just my memory map and my config file. Yeah, let me just quickly show you this config file before we end today's episode. So what's this config file? Well, let's open it and see. So I did my config file. It's also just a file full of constants like this, but they are the kinds of things that maybe at some point I want to change some values. So for example, here it says player color light red. Now everywhere in my code where I need to reference the color of the player, I don't write, oh, light red here, light red there. No. Everywhere where I reference the color of the player, I use this label. So by doing it that way, making sure that everywhere I'm doing something with the player color, I'll write this label. That means that at some point I can say, oh wait, I want my player to be green. Then I can just go into my config file and change light red to green here. And that's going to be sort of updated all over the code. It's not updated, but since I've used a label like this, everywhere that I used that label, it just points to this, right? So I just need to update the player color here in my config file. And that's the same for all of these. So for screen, for example, I just put in here screen width 40, so 40 characters wide. Screen height 25 characters tall. And let me show you another thing here. If you go down to rooms, I have something with rooms here. So I say here, room width. How wide is my room? It's 16 tiles wide. Room height 12, so 12 tiles tall. And then here's another thing that we can do. I have a label here, or a constant called room size. Now what we can do multiplication here within the labels themselves, or the constants themselves. So I say room width, this thing, times room height, this thing. Now this is not something that we can do in assembly language. So this isn't really assembly language. This is just something that the assembler, kick assembler, allows me to do. So I can do that simple math here. Room width times room height, 16 times 12. And that's gonna be the room size. So the way this works is that when I run the code, the assembler figures out all this, and whenever I use the room size, then the assembler did the math before translating this label to a number. So I don't know if that makes sense, but anyway, we can do simple math like this when working with constants or labels like this. But we can't say in our code, we can't do multiplication or division in normal assembly code, LDA and all that. So this is just for the labels, the constants. Again, hopefully that makes sense. But the point is with my config file is that I just set up different values like this in this config file. And I need to make sure that everywhere in my code where I use these different terms, I use the label numbers, label names, and not these numbers. So let's say that I redesign my game. I want my rooms, levels, whatever. I want them to be not 16 tiles wide. I want them to be 10 tiles wide. Then I just go in and change that here. So if I did everything right when writing my code everywhere else, then that's going to work out just fine, because everywhere where I've programmed something with room width, it's just going to point at this number. So I just need to change this to 10, for example. if that's what I want to do. Again, hopefully that makes sense. But anyway, I just wanted to show you that it's really handy to have a config file like this. And if we go back to my main.asm file, we can see here at the top I have import memory map and of course the folder name, so system memory map, and the config file, and I also have my constants here. All of my contents file are crammed in here, and also macros. Now, I haven't looked up macros yet, but the thing is that all these things are not going to take up any directly take up any space in memory. So that's why I have them here at the top. So they do need to be a part of the code here before we run it into the assembler, but they are not going to be at a specified memory address because they don't take up any space. There's not going to be something like this. So I just put them up here. So they need to be a part of this file so that it works out when we send it to the assembler. Yeah, hopefully that made sense. All right, so this was again quite a lot. Hopefully you can see what I mean, and hopefully you can see the point of doing it this way. So yes, you can make a gigantic file, one file with all your code, whatever you want to make. I don't recommend that. So splitting things up like this, making it tidy, spending a little extra time setting it up like this, it's really gonna pay off in the long run. So, well, that's it for now. So, have a great day. I'll see you next time. Bye bye.